Hello, my name is Keshwani. That's Keshwani, Keshwani. I have been solving math problems, data sufficiency problems for GMAT out of this book here, GMAT Review, the official guide, the 12th edition. If you do not own this book already, purchase one immediately. You should be able to find it at nba.com. The problem that I'm about to solve is the one that you're going to find on page number 276, number 42. Turn to that page, 276, and read the problem with me. Otherwise, you will not be able to follow the work. They tell you that the picture above shows the circular cross-section of a concrete pipe. So they give you the cross-section of a concrete pipe, which looks something like this. You have a smaller circle, and then you have an outer circle. And apparently, this is all concrete. And that's your pipe right there, the opening. And then they go on to tell you that if the inside radius of the pipe is r feet, alright, the inside radius is r feet, and they also go on to tell you that the outside radius of the pipe is t feet, alright. So from here to here is t. What exactly are they asking for? If the inside radius of the pipe is r feet and the outside radius of the pipe is t feet, what is the value of r? They simply want to find out what is r. How much is r? Let's see if the information that they give us in the two statements are enough either by themselves or put together. Let's see, what does the first statement tell us? The statement 1 tells us, and before we do any work at all, since it is a data sufficiency problem, the very first thing we should do is write down AD BCE. First statement tells us that the ratio of t minus r to r, I say one thing and I write something else, is 0.15. Well, that's not going to be enough to figure out the r. The ratio of t minus r to r is 0.15 and t minus r equals 0.3. Well, that makes it easy. And t minus r equals 0.3. So on the top we go 0.3. Oh, first they tell you the ratio of t minus r over r, ratio of t minus r to r is 0.15, and then they go on to tell you, in the segment to tell you that t minus r equals 0.3. So you can substitute 0.3 for t minus r here, and of course we can figure out the r from here. Just divide the 0.3 by 0.15 and you get your r equal to 2. That's all. So the first statement by itself is enough. Since the first statement by itself is enough, we know that the answer, whatever it is, cannot be B, C or E. It has to be either A or D. Let's look at the second statement. Instead of starting lower, I'm going to take this t minus r and put down 0.3 there. That was our first statement. 0.3 over r equals 0.15. Let's look at second statement. The area of the concrete in the cross section is 1.29 pi. Now that is tricky. Now they're telling you the area of the concrete section. How do I find the area of the concrete section? First we have to find the area of the smaller circle, which is the inside circle. The area of the smaller circle. So area of the large circle minus the area of the small circle, this difference. You take the area of the large circle and you subtract from it the area of the small circle, And that leftover is going to be the area of the concrete part. Area of the, let's see how did I phrase it. I want to phrase it in the same way. Area of the concrete. There you go. Area of the concrete. Area of the concrete. Or I'm going to call it, instead of simply calling it area of the concrete, I'm going to call it area of the concrete ring. This ring right here. This ring right here that you see. All of this. Area of this concrete ring. That area of the ring is going to be the area of the large circle. And how do you find the area of the large circle? Which is simply pi, area of a circle, is simply pi r squared. Pi r squared. And r in this case, the radius in this case, don't get confused with this r and that r. That r is the radius of the small circle. Perhaps I should put down this r with a small letter here. This r represents the generic radius here. The radius of the large circle is t. So let's substitute here t minus the area of the small circle, which is pi r squared, which is this r right here. And that should equal the area of the concrete ring. That should equal the area of the concrete ring. And that tells us that that area equals 1.29 pi. 1.29 pi. Now, if we were to divide the whole equation by pi, divide this term by pi, this term by pi, and this by pi, what you will find out is that we can get rid of the pi's. And what we are left with is, I don't know how low you can read, t squared minus r squared equals 1.29. Is that enough for us to figure out what is r? Oh, I keep switching the notation. I keep switching between the big R and the small r. That's going to confuse the hell out of people. Since everywhere else is a capital R, let's make this a capital R. Is there any way to figure out the value of r from that equation? The answer is no. We cannot figure out the value of r unless we know something about t. And the second statement tells us nothing at all about the value of t. Therefore, second statement by itself is not enough. Second statement by itself does not do the job of telling us what that r might be. Therefore, the answer is A. The answer is A in this case. And that's all there was. That's the end of it. I hope you found it helpful. If you wish to get hold of me for personal private tutoring, face-to-face tutoring, or tutoring via Skype, through the internet, or by the telephone, you can go to my website at www.prep.gmat.com, or you can go to www.keshwaniprep.com and send me an email. Alright? Thanks.